Video, I'm going to go over composition of functions. Now, this is probably one of the more challenging lessons that we'll have for this entire unit, just because it can be a little difficult to get your brain to wrap around the idea of composing one function into another. So I'm going to first go over kind of reviewing operations with functions, so some adding, subtracting, multiplying, and dividing, and then show you how that's different from composition of functions, and then eventually move to how to evaluate composition functions when they ask you to evaluate at a certain value for x. So these are our objectives for this lesson. So this first example, I'm going to go over some operations with functions. You'll notice I have g minus f of x, which is g of x. G of x minus f of x is what I'm going to write down. So I'm going to write down my first function, which is g of x, or x squared minus 1, and then subtract f of x, which is x minus 1. If you want, you can distribute that subtraction onto the second function. I just subtract like terms, so x squared, and then there's no x value in the first function, so it'd be like nothing, or 0 minus x, which is negative x. And then a negative 1 minus a negative 1 is actually 0, right? That's going to become 0. So this is our new function, which is g minus f of x. All right, so that is what they wanted me to do for the first one. Then it asked me to do g over f of x, which is g of x divided by f of x. So I'm going to put g of x on top again, x squared minus 1 over f of x, which is x minus 1. Now, I'm hoping you notice that this numerator is actually a special case that we can factor. It's called dots, or the difference of two squares, which is the same as x minus 1 and x plus 1. And then when you factor that, you should notice that we have the same factor on the top and on the bottom, x minus 1. So this g over f of x becomes just x plus 1. But you have to write a value that x cannot be equal to. These are called values that would make 0 in the denominator. And so we can't use 1, because if I were to plug in 1 to the original before I crossed it out, I would end up getting 0 in the denominator. So don't forget to include that if you need to. So this is the second operation. All right. Now, this lesson really is a focus on composition, but I want to show you this first example to kind of refresh your memory that you've done this before in algebra and algebra 2. You did adding, subtracting, multiplying, and dividing of different functions. And now we're going to get into kind of the more challenging component, which is composition. All right. So a lot of students will joke around and say this looks like fog, right? It's f of g of x. Most teachers and mathematicians will end up writing this notation, but both are the same thing. So you're going to see me write f of g of x, or g of f of x, or whatever the letters are, a lot. And essentially what I just want you to think of is, once you locate the outside function, all right, just copy that down. But instead of writing x, you're going to put a big box, and in that box is where you're going to put the other function. All right, so really you've been practicing so much in algebra, like how to do f of 2 or f of negative 1. And so it's the same idea, but instead of just a number, it's an entire function that's going into a certain function. All right, so let me show you two examples here. So first, I'm going to do f of g of x. You'll notice my outside function is f. So I'm going to write down 2x plus 1. But notice, instead of putting in x, I'm going to put a giant box. And in that box, I am going to put my g of x function, right, my inside function. So this g of x function is going to go inside the box in parentheses. All right, and that's really kind of the setup. If you can do that, the rest is just simplifying order of operations, combining like terms, that kind of thing. So I'm going to distribute. 2 times 3 is 6. 2 times negative x is negative 2x. Bring down the plus 1. Keep going. And I'm going to write it in order. So negative 2x plus 7. So this is f of g of x. That is called composition. Let's do another one. G of f of x. All right, so I'm going to write down the outside function is g. So I'm going to write down 3 minus x, but notice instead of writing x, I'm going to write 3 minus box. And in that box is where I'm going to put my inside function, which is f of x. in parentheses 2x plus 1. This one, I don't have a value or a number in front. I have a negative, which is really like -1. So if I distribute that -1, I get -2x minus 1. And if I combine like terms, I get -2x, and 3 minus 1 is 2. So this is g of f of x. So that's kind of the process, and I'll be helping you guys with this, and I'll be really steering you towards using this idea of writing the first function you see, right, the outside function, writing it out, but instead of putting an x, put a big box, and in that box, put the other function. Okay, so let's do, or you're going to practice these on your own, right? The first one is with some operations of functions, and the second one is the composition. But let's look at how to compose when you're given a graph. All right, so this one, actually, you know what? I'm gonna do that second. Let me show you how to compose when you're given a function. All right, so or the actual functions, not the graph. So this is to do f of h of 1. So I really think there's kind of two ways that I look at composition. There's, if this would have said f of h of x, I'm going to do that just like I taught you before, where I write down the f of x function, put the different boxes, since I have two different x's, and it put the 3x plus 2 into both of those boxes, right? That's how I did that first example of composition. But if you're given a number instead of x, so this is f of h of 1, I first think of this as ignoring the outside function and doing h of 1. So you'll notice I haven't done anything with f yet. So let's do h of 1 like we did a few lessons ago. So 3 times 1 is 3. 3 plus 2 is 5. So this is h of 1. All right, so now watch this. Let's see if your brain can do this. I'm doing f of h of 1, but remember, that's the same as doing f of, and you just found that h of 1 is 5. So I'm going to do f of 5. So what my brain understands, I'm hoping yours will learn too, is that if you find that h of 1 is 5, you can replace that h of 1 with that 5. Okay, so now I'm going to do f of 5, which is going to be 5 squared minus 5. 5 squared is 25. Bring down the minus 5, and you get 20. So this, all right, is f of 5, but the whole reason you were doing f of 5 in the first place is because you found h of 1 was equal to 5. So this is f of h of 1 equals 20. So when I see a number here, right, so when I see, like, in this case, we had f of h of 1. Because that was a number, I really think about doing two separate evaluations. First with the inside one, so that was h of 1. And then once I get that value, use that to go into the outside function. Okay? Now, let's go back. And with that same understanding, let's do this same thing with graphs. So really when I do this, I'm thinking first g of 1. All right, I'm ignoring the outside function. So if I go over to g of 1, I find where x is 1. Here's x is 1. Where is the function? It looks like, I'm going to estimate it since it's kind of like not on it. I'm just going to say for our purposes, I'm just going to put 3, even though it's kind of a little, not really 3, but close enough, right? You get the idea. So g of 1 is 3. So again, I'm not done. I'm not saying the answer to this is 3. But now when I do f of my function or my value, right, this whole thing, see if this will help. This whole thing, g of 1, is 3. So I can replace that g of 1 to be just f of 3. All right, so go to my f function. Here's 3. 3 looks to be actually the maximum because that's 3 comma 6. And so I get 6. So to kind of write down the whole thing, f of g of 1 is 6. This is my answer. So that's kind of the process for doing evaluation of composite functions when you're asking to do it with a value, like a number, all right, like example 3 and example 4. And then remember the difference if you're asking for an actual like function. There's no number, right? It's an x. So that's how you do it with the boxes. So I'm going to steer you towards those two different ways with your links, your Delta Math links. Here's some at your board questions to try on graphing and evaluating, and some exit ticket questions if you'd like. But again, during our practice time, I'll be helping you sort out how to know when to do which process.